Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always it is an honor and a privilege to be serving you today, as it is every day here in my virtual classroom. I've been asked a couple times from students, Mr. Robinson, are you reading a script when you say that? No. Am I saying the same thing over and over? Yeah, I think I can recite that till I'm old and withered. That being said, I kind of am a little old, just not yet withered. No, no, it's just something that I say. It's my script without reading something. I'm looking at you guys, the camera, the audience here. Let's go to the math. What are we talking about here? Integrated Math 2. They're going into their final exam of the year. Not literally a final cumulative exam, but their last one of the semester, the fall semester here, just in one particular unit, which is solving quadratic equations algebraically. I was going to say solving algebraic equations quadratically. All right, so solving them algebraically here. Now, we've done things where we've graphed quadratic equations. We did that in the last unit. So this one is all about factoring, completing the square, and quadratic formula. Or solving by factoring, solving, completing the square, solving the quadratic formula, using the discriminant, finding the number of real solutions to a problem. There are some word problems that we're going to look at as well, things like that. All right. So I've done this before with some other videos as well. If there's ever a problem where I can solve more than one way, I will see to it. I'll see to it that I can. And I'll give you kind of my ranking in which ones I like the most and why, which is not always the same for everyone. Generally so, a lot of people don't like completing the square in some instances, and I'll kind of give you instances where I'll be fine with it, and I'll show you how to do it. And some people are having trouble solving factoring in certain ways as well, but sometimes you're required to factor. So when you guys look at the worksheet that I'm going to give you guys, it's a practice test, if you will, or a review for their, it's a study guide. If you guys go to the description section down below on this thing here, you'll see a PDF which you can download and print out, or just handwrite, because they're just equations for the most part, a couple word problems, but you have the model of the equations on them. And within that, the very first problems you're going to see here, they just ask you to factor. They don't say to solve by factoring. There's no equation. It's not set equal. You're factoring. So you still have to know to factor there. And some problems has to complete the square only and then factor it down. So there are some things you're still going to have to know how to do. And not necessarily you, but just, students. Make sure that you're open to any way. That way some problems can be easier. Even though you can solve every quadratic equation using the quadratic formula, you can do them all completing by completing the square as well, but some of them aren't as easy to do by completing the square. So even though you can do them all by quadratic formula, and you're maybe really stubborn into only using quadratic formula, I do urge you to reconsider these other methods, as some can be so much easier for you, all depending on what's there. All right, without further ado, guys, let's go ahead and get started. And I'm going to show you the sheet right here. Modules 8 and 9 come out of our textbook. This is it's not Big Ideas Math. I don't remember what the actual title of the book is called. That's kind of bad. But let's go ahead and look down below. Number 1, parts A through F. Factor the following completely. If the polynomial cannot be factored, write not factorable. Now, I haven't seen these problems yet. Some of them will be much easier than others. Depends on what's going on. But when they say factor completely, that means greatest common factors go out first. So GCFs, any greatest common factors must be included, and you really should begin with them. This isn't just a encourage suggestion thing. This is almost a must. Not that you have to, but it's going to make life so much easier that you do. All right, I have a quadratic trinomial with no common factors whatsoever, so I need to see, with a 1x squared, can I find out what two numbers multiply to make positive 8 and add to make negative 6? And I'll let you know what I'm doing right now is not what I personally do as an individual. It is not something that I'm going to continue doing through every single problem. At some point, the strategy that you'll see here is what you can do on your own, but I'll kind of provide the answer because it's leading toward a greater cause, the next thing that's coming, because I got this answer in my head a long time ago. All right, so that's something I want to save time, cut corners whenever I can. What I'm going to do, guys, I'm going to list factors of 8, which are 8 and 1 and 4 and 2, and I'm writing them as if I'm dividing by 1 to get 8, dividing by 2 to get 4. Now, I need to add two numbers that make negative 6. Now, because the positive product here, I will either have two positives or two negatives, but because the negative sum, I'm looking at sets of two negatives here. Do either of these two sets, either negative 8 minus 1 or negative 4 minus 2, give me negative 6? Well, the answer is yeah, negative 4 and negative 2 give me negative 6. So these are the two numbers that go here. Now, in a 1x squared with the diamond method, if you go and do that, that means this factors down to x minus 4 times x minus 2. And actually, y'all, that's it. That's my final answer, x minus 4 times x minus 2. In a 1x squared, it's that easy. At some point, I might show factoring by grouping or something to some individuals who do that, but I don't have to for a 1x squared. It's when it's not a 1x squared. You will not see me use the diamond in a non-1x squared unless I decide to show factoring by grouping. I might show it in one of these, depending on the problem. All right, part B, 6x cubed minus 30x squared. You know, this isn't a quadratic yet, and that's because this x cubed is here. But I can actually factor out 2 powers of x from both terms here. I could factor out an x squared from here, and all that I'll have left here is an x, and then in the other term, I'll have some sort of constant, because the x squared divides out. Don't let the common factor stuff fool you too much. 6 and 30, I could also factor out a 6 from both of these ones right here. If I factor a 6 out, put an equal sign. If I factor a 6 out right here, I am left with just an x, just an x right here, and 30 divided by 6 is 5, so I get x minus 5. I probably spoke on that kind of strangely in that answer. I want to just say I'd factor out a 6x squared, and this is what I'm left with. I'm pulling out the greatest common factor of both terms, and I'm asking what remains in here afterward. 6x squared times x is 6x cubed, and 6x squared times negative 5 is negative 30x squared. And that's it. I'm done. It's not an equation as well. You're just factoring. That's all. All right, part C, back to a trinomial where once again I don't see a greatest common factor. And it's just too bad that I can't factor a 2 out of here, because that means I have to deal with this in kind of its own right. I have to find a way if it's factorable. And if it is, this is what I like to do, guys. If it's factorable here, I'm going to write it as this times this. I know that all quadratic trinomials have this kind of phase in it. And I know it'll have some sort of 2x times 1x right here because 2x times 1x is 2x squared, and 2 is a prime number. That's the only way I can get it. Now, I need to look at numbers that multiply to make negative 11, which, you know, here, look, I'm going to put a plus and minus right here. I have a negative product. I'm not going to overteach this, guys. I've taught it before, and I think I have videos for it, so I'm not going to get too deep into this, but I'm saying the process I'll do right now. My factors of 11 are 11 and 1, so I have one of two options here, either 11 and 1 or 1 and 11. And I know I'm trying to add to get negative 10. If I get positive 10, then that would be fine as well. So let me start with the first two. I'm trying 2 times negative 1 is negative 2, plus 11 times 1 is 11. Negative 2 plus 11 is negative 9. Really close to negative 10, but that one did not work. So now let's try 11 and 1. 2 times negative 1 is negative 22, and 1 times 1 is 1. Negative 22 plus 1 is negative 21. That one didn't seem to work either. I am under the impression in this problem right here, which I was kind of when I started looking at it on my own while I was talking, I'm under the impression that I've exhausted all the things which I should bother trying, and this appears to be non-factorable. If I can't get those things to fill in through FOIL by all factors of 2, which are just 2 and 1, and all factors of 11, which are just 11 and 1, and given the negative product, 1's plus, 1's a minus, it doesn't matter if I put a minus here and a plus here. That means I'll get a positive 9 and a positive 21 by putting those numbers where they are. Because of that, because I can't get negative 10, I'm going to go ahead and decide and say this one, guys, is not factorable. Now, we're going to learn when we do later problems here that not factorable does not mean there's no solution to those answers. I mean, you should already know that. But me writing this does not mean you would stop on a problem that said equals 0, for example. So I would probably keep going. I would keep going on a problem like that. All right, part D, x squared minus 121. You have two options for this one. I want to go for the one that you should consider first. This is a classic case of a difference of two squares problem, a squared minus b squared, where that factors down to a plus b times a minus b. It's been taught before. I'm not going to state why that is. You can distribute and check it out. The middle term cancels. But right here becomes an a plus b, a minus b. If you recognize that these two things right here are perfect squares in their own right, like x squared is squaring x, and 121 is squaring 11, and I can subtract those two, this could essentially be my a, and this could be my b, which means this factors down to x plus 11 times x minus 11. And I'm good. That's it. That's the answer. Alternatively, I could also take this thing and I could rewrite it as a quadratic trinomial where it's missing the linear term. And if it's missing the linear term, that means the coefficient must be a 0. So I could write it like this and go into that kind of diamond method question asking again. I could say what two numbers multiply to make negative 121 and add to make 0. See, that's the number that's missing. That's why it's worth writing it in a case like that. One second, my computer's doing a weird kind of fan noise thing. I'm gonna talk when I'm right here. So the two numbers that multiply to make negative 121 add to make 0. If numbers add to make 0, either they're both 0 or they're both additive inverses, which means one's a positive and one's a negative version of that number. So you're trying to find the same number that multiplies by itself twice to make 121. That number's 11. So I'm getting 11 and negative 11. Seems like the computer's still making that sound. I hope you can't pick that up. It's a weird, it's a loud kind of, I don't know how to say it. It's a weird whirring. So that becomes x plus 11 times x minus 11. Boom, right there. And it's the same answer as we got before. Okay. All right, so same answer either way there. Okay, part E. 2x cubed plus 14x squared minus 36x. All right, I see x's in all three terms. I'm definitely going to factor out an x. All of these are even numbers. I can definitely factor out a 2. So I'm factoring 2x out of each term, and what remains? 2x times what gives me 2x cubed? Well, 2 times 1 is 2, so a 1, but I don't need to write a 1 if I have an x in there. In fact, I have 2 powers of x. I have an x squared. 2x times what gives me 14x squared? 2 times 7 is 14, and x times x is x squared. And finally, 2x times what is negative 36x? That's a minus 18. Now don't stop here. You got to check and see if this part inside is also factorable. So right now I'm at this 2x times this stage, and I'm going to continue attempting to factor here. I'm going to factor down to 2x times something here. Excuse me. If I can factor this down, which I can. If I can factor this down, then I'm going to write it as here. That would be a complete factorization. You got to leave the 2x on the outside. Now, if I could not factor this, I wouldn't say not factorable because I factored something. I factored out the 2x. So this would be my final answer if that's not factorable, but it is. I got to find what two numbers multiply to make negative 18 and add to make positive 7. So negative 18, because it's a positive product, we're trying either 18 minus 1, 9 minus 2, or 6 minus 3. All right, well, 9 minus 2 gives me that 7. So that's the plus 9, and minus 2 right there. 9 times negative 2 is negative 18. 9 minus 2 is 7. That's where that thing comes from. And that's my final complete factorization. And correct, by the way. All right, the last one, 3x squared plus 14x plus 8. Let's factor that down. No common factors anywhere. That means I will have to play with the mental factoring thing. So let's go ahead and break that one down too. This is some sort of 3x times 1x, as 3 is a prime number. Because everything's positive, I know there will be a plus and plus. So, what are factors of 8? I have 8 and 1, 1 and 8, 4 and 2, or 2 and 4. Which ones will give me what I need? I might as well try them all. Let's try 8 and 1. That'll be 3 times 1 is 3, plus 8 times 1 is 8, 3 plus 8 is 11. That's not 14, so that doesn't work. Hopefully you know what I'm doing here. I'm foiling. I'm multiplying outside with inside, and I'm combining like terms there. I've done it a lot before, so I can probably run through a different video. Probably link you to a different video if you're looking for it. 8 and 1. 3 times 8 is 24. 1 times 1 is 1. 24 plus 1 is 25, not 14. So it's not 8 and 1 or 1 and 8. Let's try 4 and 2. 3 times 2 is 6. 1 times 4 is 4. 6 plus 4 is 10. That's not 14. My last chance is if 4 here and 2 work here. 3 times 4 is 12. 1 times 2 is 2. 12 plus 2 is 14. This one works. Therefore, this is the factorization. You can FOIL to double check, but that's what I kind of did. You know, I chose 3x and x because I knew that was 3x squared, so I've already taken care of first. I'm choosing factors of 8, 2 times 4, 8 times 1, thing like that, so 8's already taken care of, that's last. All I'm doing is outside 3x times 4 plus inside 2 times 1x, and I'm getting 14x there. So there is really no double check needed because I did kind of just double check, right? That was the thing. Now, for those who are factoring by grouping, here's kind of what you would do here. You would take the two, and I'm not going to spend long on it because if you already know what you're doing, awesome. If not, you probably wouldn't do this method. So here I can draw the diamond, and it's not just about 8 anymore. It's about 3 times 8. And it always has been about the number in front times here. Just that before, the number's always been a 1. So 1 times 8 would have been 8. But 3 times 8 is 24. What do numbers multiply to make 24 and add to make 14? And I have a whole video dedicated to this factoring by grouping stuff, so I'm not going to explain why that is. What do numbers multiply to make 24 and add to make 14? Actually, don't know. 6 plus 4. 12 plus 2. 12 plus 2. All right, so 12 and 2 right there. So what I'm going to do, I'm going to rewrite this as 3x plus 3x squared plus 12x plus 2x plus 8. I'm rewriting this expression, but I'm splitting the 14x into 12x and 2x. I'm going to factor by grouping. I'm going to find common factors, greatest common factor of these two terms right here. That's factor out the 3x, I'm left with x plus 4. Here I could factor out a 2, and I'm left with x plus 4. And x plus 4 is a common factor that exists in both terms here. So if I factor out the x plus 4, right here, x plus 4, I remain still on this step for 3x and 2. 3x plus 2. Whoops. 3x plus 2 right there. So 3x plus 2 times x plus 4, it comes out no matter which way I put that there. So same answer, same bit, different approach. All right, that's factoring completely and correctly there. Now let's look at number 2. Complete the square. Oh, it says compete. That should say complete. That's my fault. I'll try and fix that before I attach the PDF. Complete the square on the following, then write into the factored form x plus b quantity squared. So the whole goal of completing the square is to make a perfect square trinomial out of what you have there, right? So x squared minus 16x plus blank, what's the number that completes the square? Because this is a 1x squared, I'm in favor right here. I can do it. I'm going to take negative 16 and I'm going to divide it. I'm going to divide it by 2. Divided by 2 here, I get negative 8. Negative 8 quantity squared will be positive 64. So that's what completes the square, and this is what breaks it down to the perfect square trinomial here that can factor to x minus 8 quantity squared. Negative 8 times negative 8 is 64. Negative 8 plus negative 8 is 16. The two numbers that multiplied make 64, and add to make negative 16 are negative 8 and negative 8. Yes, it is this number right here. That's the kind of easy way to remember it. And that's important for the next problem that we do, because this next problem I have an odd linear coefficient, and I'm going to have to divide this one by 2. So part B, x squared plus 9x plus blank equals what it was factored to, blank. So the 9x, I divide the 9 by 2, and I get 9 over 2. Yeah, I'm going to leave it here as a fraction. That's totally fine and probably preferred. When I square that guy, I square the top, 9 I get 81, square the bottom, 2 I get 4. That's what completes the square there, 81 over 4. Yeah, it's 20.25. Yeah, this is 4.5. I'm not going to play with that right now. But let's factor this. What two numbers multiply to make 81 over 4 and add to make 9? Well, it's this 9 over 2. This is the number here, and it's positive. 9 over 2. So I'm going to write x plus 9 over 2 quantity squared, like that. And that completes the squares there. Hopefully we're not going to deal with too many odds. These are the times when I would not solve a quadratic by completing the square, when I have an odd linear coefficient. All right. Number 3, these things would be used in quadratic formula most often. Find the discriminant of each quadratic equation and determine the number of real solutions. 4x squared plus 8x plus 4 equals 0. I have a common factor of 4 I'd like to just get rid of right now. You can totally do that. That's a plus 2x, sorry, 1 second. X squared plus 2x plus 1 equals 0, and I can now divide them all by 4. I could have divided by 4 from the beginning. In fact, I probably will next time, but just to show you that factorization first. All right, x squared plus 2x plus 1 equals 0. I have a quadratic equation written in standard form set equal to 0. I can identify a as 1, b as 2, and c as 1. The discriminant in the quadratic formula, we are referring to the b squared minus 4ac. This is the part that I'm going to do right now. So when evaluating that discriminant here, y'all, I'm going to get b, which is 2, b squared minus 4ac. That is 4 minus apparently 4, which is 0. If you have a discriminant of 0, so that's the discriminant. If you have a discriminant of 0, that means you'll have one solution, one real solution. I might dig into that a little bit more when I actually do quadratic formula, but the way that we talk about these are if this is greater than 0, we have 2 real solutions. If it's equal to 0, we have 1 real solution. I don't know why I wrote the number 1 here. That's okay. And if it's less than 0, if it's negative, then we have no real solution. Solutions. None. They're complex solutions. All right. Part B, x squared plus 5x equals 0. It is in standard form and set equal to 0, and it's reduced. I got to identify C, though. See, my A here is 1. My B is 5, and I don't see a constant term. That must mean it's 0. Okay, fair enough. So let's go ahead and do the discriminant guy there. That discriminant will be b squared minus 4ac. That's 25 minus, hey, 0. That becomes 25. The discriminant there is 25. That means they're a positive number. That means there are 2. Nice, look, I spelled it out again. 2 real solutions. I might spell it out a lot. Just up top I did not, because I wanted to show the 2, 1, and 0 as actual numbers. 2, 1, 0. 2 real solutions for a positive discriminant. B squared minus 4ac. The last one, part C right here, it's not yet set equal to 0. So if I add 7x over and if I add 3 over, I can write this in standard form, get a plus 7x, get a plus 3, set it equal to 0. That way I get my proper A, B, and C. My A is 8. My face will be in the way here in a second. My B is 7, and my C is 3. And let's see what we get here with b squared minus 4ac in the discriminant. We'll get 7 squared minus 4 times 8 times 3. That becomes 49 minus 32 times 3 is 96. You know what? Like, what's the number? I don't know. 47, negative 47, I think. The point is it's negative. I got a discriminant and a negative value here. That means there are no real solutions here. No real solutions right there. And that's that final answer there. So one of these was 2, one of them was 1, one of them was 0. I don't know if you can expect that if you had a test. But that is what you would get for those 3 results. The discriminant's the b squared minus 4ac, part of the quadratic formula. That tells you how many solutions there are off the bat. And if you evaluate that as no real solutions, in Algebra 1, we wouldn't have to keep going. In Math 2, you would not, hang on my computer again, you would not have to keep going in a problem like that. You're kind of done at that stage. Okay, moving on to the next page here. If you printed this out, just find the next page. All right, solve the following factorable quadratic equations. Now, here's the thing. I did not make this review sheet, okay? This review sheet originally asked us on this stage of problems to solve them by factoring. I'm going to go ahead and tell you that if I see another way that I probably could and should maybe do it, if you want to look at it, I don't mind you using that method. The reason I assume these ones are factorable. If they said solve by factoring, I assume they wouldn't give you an equation where you try to factor, determine it's not factorable, say not factorable, and move on. Because not factorable doesn't mean there isn't a solution. It just means there's no rational solution. So I'm assuming, I haven't done these before, but I'm assuming that if they gave me these equations in the place where they said solve by factoring, I assume they're factorable. If I see another method, I'm going to try it, another viable method. So I'm going to show you all different opportunities. That's what's going to make this video a little bit longer, okay? But make sure you bear with me on that. These are methods you might consider trying, or you might not even recognize they're factorable along the way. But this is where I might go a little bit faster now that you've seen factoring and completing the square, and you've seen the discriminant and quadratic formula. So I'll attempt by factoring for all of them to begin with. So let's start by factoring on part A. X squared plus 4x minus 21 equals 0. If it's factorable, I should be able to get some x and x right here. What two numbers multiply to make negative 21 and add to make 4? That is a positive 7 and a negative 3. So that's what it factors down to. Now, in solving by factoring, we use something that's called zero product property. If two things multiply, that's why we factor it. We create a product. If this times this equals 0, either x plus 7 equals 0 or x minus 3 equals 0. If x plus 7 equals 0, then x equals negative 7. I subtract 7 from both sides. And if x minus 3 equals 0, I add 3 to both sides to get x equals 3. So those are my two answers, and I've solved by factoring. There are other viable methods here, though, such as completing the square. So I'm going to do that one next. In completing the square, I should add the 21 to both sides to get it out of the way, because I'm going to find a number that will give me a perfect square trinomial right there. Now, I added 21 to the right side here, and whatever I'm going to add to this side to complete the square, I will add to this side as well, because that's a property of equality. I added 21 to both sides too, and whatever I'm going to add here, I also add to both sides. I take my 4, my linear coefficient, I divide it by 2. 4 divided by 2 is 2. Square the 2, I get 4. That's the number that completes the square here. 4 and 4. The reason I do that is to factor this down to a perfect squared binomial quantity, that's x plus 2 quantity squared. And 21 plus 4 is 25, because now I can solve using square roots. I take the square root of both sides here. That cancels out and leaves me with x plus 2, provided that I put plus or minus. And the square root of 25 is 5. So x plus 2 equals plus or minus 5. If I subtract 2 from both sides, I'm going to get x equals negative 2 plus or minus 5. So x will either equal negative 2 plus 5, or x will equal negative 2 minus 5. Negative 2 plus 5 is 3, and negative 2 minus 5 is negative 7. Although this didn't take super long, it still took a lot longer than factoring. So if you have means of factoring, I always say go for it if you can. That's why I'm going to really attempt to do that each time here, even though I took away the whole you must do by factoring. So I'm going to try and divide some stuff up here a little bit so you can see them a little easily. One more way I'm going to use this quadratic formula. Quadratic formula. And in quadratic formula, it's already set equal to 0, so let's identify A, B, and C. And let's use that discriminant here. The discriminant is going to be B squared minus 4AC, which is 16 minus a negative, which is plus 84, and that's 100. Now, 100 is the thing I'm going to take the square root of, right? That's inside the quadratic formula. Let me write it out because I haven't written it yet. That's not how it goes. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is true in a quadratic equation, the standard form that's set equal to 0. ax squared plus bx plus c equals 0, provided that you have this condition already met. That's why I keep saying if it's set equal to 0. If this, then that. If this, then that. So here we go. On this guy right here, I'm going to do x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's x equals negative 4 plus or minus square root of 100 is 10 all over 2. So x either equals negative 4 plus 10 over 2, or x equals, let's see. I don't have much room. Let me do this first. Negative 4 plus 10 is 6. 6 over 2 is 3. Or I could do x equals negative 4 minus 10 over 2, which is negative 14 over 2, which is negative 7. There we go. X equals 3, x equals negative 7, x equals 3, x equals negative 7, x equals 3, x equals negative 7. Sorry, kind of ran out of, you didn't see there. All right, it's a lot of space used up there. Part B, thankfully, I'm probably only going to use 2 methods, not 1. I don't like using completing the square here on part B as I'm looking at it. It looks a little, you'll see what I mean. All right, part B, 5y squared plus 6y plus 1 equals 0. I'm attempting to solve by factoring first because apparently it should be factorable. This one should be pretty straightforward as well because I have prime numbers on both and everything's positive. So there's not much wiggle room here. So if it's factorable, I'm looking at this stage here. It's set equal to 0 already. I'm looking at a 5y and a 1y, and plus because everything's positive, and the only two factors of 1 are 1 and 1. So if this doesn't work, nothing works. 5 times 1 is 5, 1 times 1 is 1, 5 plus 1 is 6. Boom, I got 6. It seems to work out. So this is the factorization. I'm already set. So if it factors down to that, I'm going to get either 5y plus 1 equals 0. If I subtract 1 from both sides, I get 5y is negative 1. Divide both sides by 5, I get y equals negative 1/5. And if y plus 1 equals 0, I subtract 1 from both sides, I get y equals negative 1. So my two answers I get are negative 1 and negative 5. Are there any questions to the room of no one else that I'm talking to? I'm just stalling as I start to write these boxes. This is going to get really cluttered, guys. My apologies. There's no real way around that, since I did these all on this page to begin with. All right, solving using the quadratic formula next. Okay, I'm not using completing the square because even though you say this is a linear coefficient, I could divide it by 2 and square it. One of the things on solving by completing the square is you need to have a 1 quadratic coefficient, a positive 1. And I could factor the 5 out of this with this term, but factoring a 5 out of 6 leaves me with 6/5. That's not fun to work with anymore. Now it's a fraction. So it's of no good to me to make that one work. Okay. So just kind of keep that in mind when we're doing that. All right, so anyway, quadratic formula is what I'm going to do instead. And in quadratic formula, I'm going to recognize A is 5, B is 6, and C is 1. And the discriminant of that will be B squared minus 4AC, which is 36 minus 20, which is 16. 16 is my discriminant. So when I use quadratic formula here and I get, it's not x equals anymore, now it's y equals negative b plus or minus the square root of, here's my b squared minus 4ac, all over 2a. That's going to be negative 6 plus or minus square root of 16 is 4, all over 10. So y will either equal one of two things. It'll either equal negative 6 plus 4 over 10, or negative, I know my face is going to get in the way here, negative 6 minus 4 over 10. Negative 6 plus 4 over 10 is negative 2/10, or negative 1/5. Ja? And here y is negative 6 minus 4, which is negative 10, over 10, which is negative 1. So there we go, negative 1/5 and negative 1 right there. Getting bruising on my hand by finger by writing so much right here. I already did a previous video and I got another video to do afterward. All right, let's move on forward. Number C is an interesting when it comes to completing the square. I'll talk about it when we get into it. But did I say number C? Letter C. On C right here, let's try and solve by factoring first. I got to find out what two numbers multiply to make positive 100 and add to make negative 20. And that becomes a negative 10 and a negative 10. X minus 10 times x minus 10 equals 0. So either x minus 10 equals 0 or x minus 10 equals 0. And that sounds dumb. And you know what? That kind of is dumb. Because it's dumb sounding. That's why it sounds dumb. I'm saying the same thing twice. Either x minus 10 equals 0 or x minus 10 equals 0. So x either equals 10 or x either equals 10. You don't have to say this twice. Just say it once, you're good. There's something along the line of multiplicities that you would talk about. That's more of a algebra 2 pre-calc kind of thing that you would talk about when you talk about multiplicities of the thing. There's only one solution here. It's 10. And actually, that'll be important for me to say there's only one real solution, because when we do the discriminant of this in quadratic formula, you'll see the same thing. Now, completing the square is kind of an interesting nugget for here, because remember what completing the square is all about, and I'll still do it. But what completing the square is all about generally is moving the value over, the constant term over, because you were trying to place in another number that would complete the square. So I would subtract 100 over x squared minus 20x plus some unknown, and when I subtract 100 over, I'll add this unknown. Negative 20 divided by 2 is negative 10, and negative 10 quantity squared is positive 100. So interesting, I got the same number back out that I had originally. So there are kind of two morals to this tale, and by the way, I can still do it this is kind of factoring, but you'll see what I'm talking about. There are kind of two different ways we can talk about this. You know, I didn't have to move this thing over because this was the number that made a perfect square trinomial. So if you already know your perfect square trinomials, you don't need that extra bit there. You can just write and factor down to x minus 10 quantity squared. Now, negative 100 plus 100 is 0, just like the 0 we originally had. So we kind of wasted time doing that, but we're down to what we need to. Now, you might ask, is this solving by factoring? Sort of. But this time I'm going to solve using square roots, if that makes sense. If I take the square root of both sides right now, then here I'll get x minus 10 equals, and it's probably not important to put plus or minus 0, but it gives me emphasis for something else, so I will. So add 10 on both sides, I get x equals 10 plus or minus 0. So either x equals 10 plus 0, which is 10, or x equals 10 minus 0, which is 10. And that's one of the points I'm going to make here. I'm adding or subtracting 0. When I add or subtract 0, my value does not change. And this is one reason we have one solution here, because I'm adding nothing to this 10 that comes here. That's where I just get that one answer of 10. Okay, anyway, that's kind of solving by completing the square. At least I did the process, but there were kind of wasted moments in there. I could have just factored it down, and at that point it's kind of solving by factoring because it doesn't change kind of what results in the end there. My last one I'm going to use is quadratic formula. So let me split this up a little bit more. My apologies, guys. All right, here we go. All right, quadratic formula. Set equal to 0. My a value is 1. B is negative 20. C is 100. Sorry. There we go. All right, discriminant. Discriminant. I'm going to get b squared minus 4ac. Positive 400 minus 4 times 1 times 100 is 400, which is 0. This is one of those examples where you'll have, remember when your discriminant is 0, it's one real solution. Let's check it out. X equals opposite of negative 20 plus or minus the square root of 0, all divided by 2 times 1. Opposite of negative 20 is positive 20, so it's 20 plus or minus 0 over 2. So add 0, you still get 20. Subtract 0, you still get 20. So 20 over 2 is 10. X equals 10. That's why a discriminant of 0 gives you, and I kind of talked about it here, but that's why a discriminant of 0 gives you one real solution only, because you're not adding or subtracting anything. Square root of 0 is 0, and then adding 0 to that, still leaves you with 0. So that's why you get that result. I know people will be kind of OCD over this, so I'm going to fix it. And that's where we get the answer. Of course, I am solving by factoring first, and if you recognize that factoring, you kind of live with that, and you're done. I'm just giving you all the other methods because you can use them, and I want to stretch and exercise them. They're possible. All right, part D, I do have, without making this too difficult, guys, in solving by factoring, I do have a difference of two squares here. This is 3x squared, and I'm subtracting 5 squared. That means I can make this 3x plus 5 times 3x minus 5 and set that guy equal to 0. If 3x plus 5 times 3x minus 5 equals 0, hang on a second, that did not do what I wanted it to do. There we go. 3x plus 5 times 3x minus 5 equals 0. Either 3x plus 5 equals 0 or 3x minus 5 equals 0. Here I subtract 5 from both sides and I divide both sides by 3. I get x equals negative 5/3. And here I add 5 to both sides and then I divide both sides by 3 like that. And I get that answer. Now this one's not really set for completing the square, and the thing about this is you really don't have to, because there's another method I'm going to do. It's not completing the square, but it's solving using square roots, and I want you to note the difference here. See, in solving using square roots, guys, completing the square is, I do that. I take the square root of both sides, but I first have to make a perfect square quantity out of it. This one has no problem with making a perfect square quantity out of what I have, because I already kind of have one. There is no x term interfering with this 9x squared. I can solve using square roots by isolating my 9x squared term. So instead, I can add 25 to both sides, and I want you to pay attention to this bit. Add 25 to both sides, I get 9x squared equals 25, and divide both sides by 9, I get x squared equals 25/9. I know we don't love fractions, but these are both perfect squares right here. If I take the square root of both sides right now, as my x squared is completely by itself, I can get x equals plus or minus. And I'm going to be taking the square root of 25, and I'm going to be taking the square root of 9. So that becomes plus or minus 5/3. Now we had gotten that answer solving by factoring as well. X equals negative 5/3 and x equals positive 5/3. This is my preferred way to solve this problem. I like the difference of two squares, actually. I like looking at that. But some people might not recognize that that's what it is, and you can solve using square roots here, provided you remember the plus or minus, provided these ones were perfect squares to begin with, and otherwise we wouldn't have been able to factor. Solving using square roots also works. These are the two solutions, plus or minus 5/3. Now, quadratic formula, I'll try and fit it in here. Sometimes I'm getting a little like, should I do quadratic formula? These ones were a lot just easier. This is set equal, this is standard form, set equal to 0. So I have a equals 9, b is 0 this time, guys, and then c is negative, boy, that doesn't fit, does it? A is 9, b is 0, c is negative 25. Hopefully you can read this bit. A is 9, b is 0, c is negative 25. There we go. So the discriminant right here, I'm going to start with b squared minus 4ac. And with that negative 25, that means I'll be adding. So this becomes 0 plus 4 times 25 is 100, and then times 9 is 900. So 0 plus 900, which is 900. So that's my discriminant. That's where I'm going to take the square root here. So I get x equals minus b, or negative b, plus or minus the square root of 900, all divided by 2 times 9. The square root of 900 is 30. Negative 0 is 0. Plus or minus something, I can just ignore the 0 portion completely. I'll just have plus or minus. So this is plus or minus, and square root of 900, like I said, is 30, and 2 times 9 is 18. So plus or minus 30 over 18, I can divide top and bottom here by 6. Divide top by 6, divide bottom by 6, and reduce my fraction to plus or minus 5/3. So I do get my answer of plus or minus 5/3 on that problem as well. And all is solved for, just like the square root version and the factoring version. All right, making good business. I don't know if I'm making good time, guys. This is gonna be a long video, but I'm doing good things out of what I have. All right, 10x squared minus 20x equals 240. Guys, I don't know if you see what I see. Do you see what I see? But I can divide everything here by 10. Please make these problems easier for yourself. Divide everything by 10, and I'll have a 1x squared problem, which simplifies everything, especially the factoring. So now I'm going to have it as x squared minus 2x equals 24. Okay. If I'd like to solve by factoring, then I must move that 24 over to the other side by subtracting it. X squared minus 2x minus 24 equals 0. So far, everything was factorable, and this one will be, now that I'm looking at it. So I assume, when they asked me to solve these by factoring, that these would all be factorable. So I'm hoping this one will be as well. Anyway, here we go. I just kind of did that one in my head already, and yeah, it is. All right, so x squared minus 2x minus 24 equals 0. I get x minus 6 times x plus 4 equals 0. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2. So if x minus 6 equals 0, add 6 to both sides, I get x equals 6. Trying to save room. This is zero product property. If x plus 4 equals 0, subtract 4 from both sides, as x equals negative 4. You're done there. Probably the way I'd solve that problem. Sorry, I wonder why my nose is itchy. People think I'm like picking a boogie. My nose is just itchy. So I'm trying to... Well, maybe I'm picking a boogie. Who knows? All right. Solve by completing the square next. I can go back to completing the square for this problem. And actually, this problem was kind of set up for it right here. X squared minus 2x. I need to add something here. But keeping the 24 on that side is exactly what I need for completing the square, because this was not a perfect square trinomial right here. Divide negative 2 by 2, I get negative 1. Square negative 1, I get positive 1. That's what completes the square there. So I add 1 to both sides. All right, let's moving on down. This factors down to x minus 1. Do that again. X minus 1 quantity squared. And 24 plus 1 is 25. Now I can take the square root of both sides right there. And that's where I get x minus 1 equals plus or minus the square root of 25 is 5. And if I add 1 to both sides, I get x equals 1 plus or minus 5. So what is 1 plus 5? Well, that's 6. And what is 1 minus 5? Well, that is negative 4. So those are my two sets of answers right there, 6 and negative 4. That's what I got in factoring as well. Doing pretty good there. Now let's solve using the quadratic formula. Let me first thin everything out here. This is where you want to do what we did solving by factoring, meaning we want to set it all equal to 0 before we proceed. So I will kind of use this mantra right here. We have it already written, so I'm just going to go ahead and identify A as 1, B as negative 2, and C as negative 24. Again, when it's set equal to 0, the C is negative. That's what I have to work with. So my discriminant here, b squared minus 4ac minus 4ac will give me, whoopsie, a positive 4 plus 4 times 24, I think, is 96. And why is it plus? I'm subtracting the negative, and that's 100. We've seen that one before, guys. Square root of 100 is 10. Let's see if I can do this in kind of quicker fashion now that I've done it a couple times. Negative b, the opposite of negative 2, y'all, is positive 2. So that's my negative b. Plus or minus the square root of b squared minus 4ac. Remember, square root of 100 is 10. Let me clarify. The discriminant is 100. The discriminant is 100, but I'm taking the square root of it in the formula, and that's where I get the 10. So b squared minus 4ac, all divided by 2a. 2 times 1 is 2. That's kind of a fast way for me to put it, if that's all right. So x either equals 2 plus 10 over 2, which is 12 over 2, which is 6, or x equals 2 minus 10 over 2, which is negative 8 over 2, which is negative 4. So again, same answer, all three different ways right there. 6, negative 4, 6, negative 4, 6, negative 4. No matter how old I get, I still feel accomplished in showing that they're all the same answer each time. Not like, oh, I feel good in getting the problem right. It's kind of cool and validating to show all different ways and say, look, all the math does connect. There's more than one way to do these problems, and there's something to that. Not rewarding. There's something kind of fanciful in seeing that develop. Seeing that happen. All right, part F is a bit of a, not a doozy, but it's kind of starting off in this strong way. They ask us to solve by factoring first, of course, but I'm all told, okay, solving by factoring. All told, I got to do this for quadratic formula. Anyway, I got to move that 7x squared and the 3x over to get 4x cubed minus 7x squared plus 3x equals 0. Now, there's still kind of a wrinkle here. See, I can't use quadratic formula right now. I mean, I kind of can. You'll see what I mean. But I don't have a quadratic equation right now. I have a cubic equation. So I have a common factor of x. Now, here's what you can't do. You can't divide everything out by x. And that's not to say that that's not allowed. It's to say that you've just removed a solution from your equation. We can factor an x out. That's why I remember that one time when I factored the 4's out. I don't know where it is, but previous page, I'm sure. Remember when I factored 4's out of something? Where are they? And then I divided right here. I first factored out. That's what I could do. I can factor an x out, but I can't divide it out because x, plugging in numbers for x is all what gives me my answers, and I can't just eliminate some possible solutions, which I would have. So if I factor an x out, I'll be left with 4x squared minus 7x plus 3 equals 0. Now, there's an interesting fly in the ointment here, and it's using zero product property more than once. I'll show you what I mean. And actually, let me take out this f and make this black and say, let me do this with quadratic formula as well. So if this equals 0, guys, what I want you to recognize is this is a product right now. This is this times this. This can be an a times b in zero product property. If this times this equals 0, either this equals 0, which, by the way, is one of my solutions. I'm done, and I'm going to leave this here. So no matter what other solutions I get, this is one of them. Either x equals 0 or 4x squared minus 7x plus 3 equals 0. Now notice I never divided x out. I factored it and listed it as a solution. But I am going to look at it as if the x no longer exists. And here's where I can solve by factoring or by quadratic formula. So on this stage, this is where I'm going to start. This is where I'm going to begin the factoring and quadratic formula. Now in factoring here, it's going to, if factorable, which I believe it is, I did it kind of earlier in my head, it'll be this times this equals 0 here. Now you either, 4x squared can either be 2x times 2x or it can be 4x times 1x. And I'll tell you what right now, I know I've said this to my kiddos before, I know it can't be 2x times 2x because when I do the FOIL and multiply outside, 2 would have to multiply by an integer to get an even number because 2 is even. 2 would have to multiply by an integer to get an even number. 2 is even. 2 times something is even. And when I add those two even numbers, I would get an even number, but negative 7 is odd. See, I need an odd solution. I can't have two evens multiplying with some other number to get that. Those won't work. The only chance is if 4x and x both work. Now, negative sum and positive product means both of these are negatives. So I can either have 3 and 1 or 1 and 3. If I try 3 and 1 first, I get 4 times negative 1, which is negative 4. X times negative, or 1 times negative 3 is negative 3. Negative 4 minus 3 is negative 7. That one works out. So I'll get that one right there. That's 4x minus 3 times x minus 1 equals 0. That's the factorization. That might be a mouthful for a lot of people there. That's my strategy. Okay, let's get this one out of the way right now. X minus 1 equals 0, so x equals 1. The other one, if 4x minus 3 equals 0, you get, add 3 to both sides, that's a 0. you get 4x equals 3. You divide both sides by 4, you get x equals 3/4, like that. Okay. That's solving by factoring. Could I fit quadratic formula up here? Maybe. Remember, I'm only applying quadratic formula on this quadratic portion right here. So in quadratic formula, my a is 4. By the way, remember, 0 is one of the answers. So I'll write these all out in black in the end. A is 4, b is -7, and c is 3. Let's do our b squared minus 4ac bit. That's -7 squared minus 4 times 4 times 3, which is 49 minus 48, which is 1. All right, because I'm low on room here. The square root of 1 is also 1, guys. So when I do the discriminant here, I'm going to be writing, or the square root of b squared minus 4ac, that's what I'm going to write there. All right, let's see. In quadratic formula, let me thin this out here. I'm still in the factoring, and I've almost run at the hour mark here. 51 minutes. All right. Give me one sec. All right. So I have x equals negative b plus or minus. Well, actually, here, I'm going to do this in one step. I'm sorry. Opposite of -7 is +7, right? So 7 plus or minus 1. That's the square root of b squared minus 4ac. All over 2 times 4. That's going to be all over 8. All right. So that'll be 7. That'll be 7 plus 1 over 8, which is 8 over 8, which is 1. Or that'll be 7 minus 1 over 8, which is 6 over 8, which reduces to 3 over 4. 3/4 right there. So I get x equals 1, x equals 3/4, just like I got down there. So the final solutions, guys, remember 0 was one of those solutions. I factored the x out, but x times something is 0. Right, if I plug in 0 to the original equation, I get 0 equals 0 minus 0. That works. So anyway, my final 3 solutions here are x equals 0, x equals 3/4, and x equals 1. Those are the 3 answers, as it was a cubic to start off with. There are 3 solutions there. All right, all of those were factorable, and I solved by factoring alongside any other things. As you can imagine, completing the square would have not been an ideal one for here. I'm going to see if eventually I can run into a completing the square one with a non-1x squared, but this is not one of the problems to do it because this is not a factor of 4. All right, let's go ahead and move on forward, guys. I have a word problem here. You are building a garden in the shape of a rectangle. The length can be expressed by 2x plus 10 feet and the width by x minus 2 feet. If the area of the garden needs to equal 70 square feet, set up an equation that can be used to find the value of x. So as a rectangular garden is, we have something like this. The length is the longer bit, that can be 2x plus 10. And the width is the smaller bit, that can be x minus 2. Yeah, these are all in feet. We'll remember feet in the end here. And the area here is 70 square feet. Now, an area of a rectangle is base times height. Oh, sorry, I should say length times width. An area is length times width of a rectangle. So my area here, my 70, is going to be the result of multiplying the length and the width. The length is 2x plus 10. And the width is x minus 2. This is the equation I'm going to use to solve this answer here. What is the value of x that can be used to have this length and this width set up? All right. So use algebra to solve your equation. What are the length and width of the garden? Now the thing is, this is already factored, but it's not set equal to 0. So therefore, I can't use 0 product property on something that's not set equal to 0. I can't even say this equals 70 or this equals 70. That's just not true. So what I have to do, it sounds backwards, but I have to distribute and expand this. So that's foiling. It's 2x squared minus 4x plus 10x minus 20 equals 70. And then negative 4x plus 10x is 6x minus 20 equals 70. Before I proceed any further, I can divide everything by 2. Let me do that in a second. Let me subtract the 70 over, just in case something else can... No, I can't. I subtract 70 over, I'll get 2x squared plus 6x minus 90 equals 0. So, and divide everything by 2, lastly. Let's divide everything by 2 now. and we can get x squared plus 3x minus 45 equals 0. Okay. Okay. What we did was we've created a quadratic trinomial set equal to 0 so we can attempt to factor. I think it's factorable. I gotta look into it. I think it's factorable. We'll see. It might not be. So anyway, let me make sure I did the math right as well. So anyway, I can't do anything with it right here, but if I factor this one down now, then I will be able to do something with it. So let's confirm I did everything right, because I might have messed up. I don't know if this is factorable here. 2x squared plus 2x plus 10x minus 2, so I get 2x squared minus 4x plus 10x is negative 6x. Oh, negative 6x. Wait a second. No, minus 4x plus 10 is positive 6x. Minus 20 equals 70. Subtract 70 is negative 90, 45. Okay, let's see if this is factorable right here, because if not, I'll probably use quadratic formula. So let's find factors of 45. I have 45 divided by 1. 45 divided by 2 I can't do. Divided by 3 I get 15. Divided by 4, no. Divided by 5 I get 9. And I think that's it. So positive product, negative product, positive sum, subtract, subtract, subtract. None of these equal 3. So this is not factorable. Because 9 minus 5 is 4. That doesn't get me 3. Assuming I did everything right, this is not factorable. Okay? I sure wish it was. Maybe they didn't create the problem with the right thing in mind and they wanted it to be, but just so happens that it's not as it stands. So what do? Well, here's where you're stuck using either completing the square or quadratic formula. Now, I'm not going to use completing the square because of this odd number here. I don't want to divide it by 2. So I'm going to use quadratic formula for this one. Say A is 1, B is 3, C is negative 45. Now, this is also where a calculator will have to be used because I'd rather that you... Even though they're approximated, I'd rather that our irrational solution doesn't say as a square root when we're talking about feet here. So here we go. Our discriminant, guys, our discriminant here is b squared minus 4ac, like that. That's 9 plus, minus negative, 180, which is 189. That's what we got to take the square root of there. All right, now also I'll give you an exact answer first, but, just keep that in mind, what's going to happen. All right, so this becomes x equals negative b plus or minus, oh, by the way, square root of 189. It's not a perfect square, but I can take out something larger than 9 I can take out. I can take, 20, never mind. No, yeah, 9's the largest. I can take out, all right, so 189 is root 9 times root 21, which is 3 root 21. So plus or minus 3 root 21, that's simplifying that radical, all divided by 2 times 1. 2 times 1 is 2, so all divided by 2. So here's an exact answer, but let me tell you a couple things about this that really make, I don't know why I put an X. Let me tell you something about this that make me really want to simplify this more in using the calculator here. All right. First of all, one of these answers actually will not work. The reason is because when we talk about widths and lengths and stuff, those numbers need to be negative. Okay, they have to be negative numbers. Positive. I don't know what I'm saying. I'm sorry. They have to be positive. They cannot be negative numbers. We can only take the square root. I'm not saying my words right. We can only evaluate with positive lengths and widths. If we compute this outright and we get a negative answer for x, we can't use it. At least we can't use something that when we plug it in for x, we get a negative length or width. We can only get positive lengths and widths. So let's evaluate what these two things are. I'm going to round them to the nearest tenth in the end. But here's what I'm going to use. Graphing calculator here. That's what I was trying to pull up. That's why my words were getting jumbled. I was trying to pull this thing up. And I'm going to do negative 3 plus 3 root 21 and divide that one by 2. That's going to give me 5.37. I'm going to store that answer as just this letter A. Okay, that's going to be one of my answers there. And then I'm going to do negative 3, whoops, need parentheses here, negative 3 minus 3 root 21 and divide that one by 2 as well. And here I'm going to get negative 8.37. Now, if I round these things, I'm going to go back to here. My answers right now, x are approximately 5.37 and negative 8.37. And I don't know if these are specifically here in feet, but when I plug them into here, they'll be it. The problem is, guys, when I plug in negative 8.37 or something along those likes there, I'm going to get negative 8.37 minus 2, which is like negative 10.37. It's a negative width, and I can't have that. This thing would also probably give me, I think, a negative length, and I can't use that either. This one's ruled out. I can't use it as per one of my answers, but 5.37 is something that I can use. Now, I'm going to be using the exact number in for this, so although I'll be writing the approximated ones, I'll be using my calculator on the exact 5.37 here. And I think when I work with my kiddos on this for a test, they're not going to be tested on something where they have an approximated answer to work with. It would just be the exact one, or they would stick with what they have as the answer, as in what is x. Okay, so right here, when I do 5.37esc, my length is going to be 2 times 5.37. Remember, it's not going to be exactly that. Plus 10, which is going to be about something. And my width is going to be 5.37esc minus 2, which is going to be actually about 3.37. I don't need to calculate anything there. But I will show you what the exact one is and why I need the exact ones for it. So the width is about 3.37 feet. And the length, let's do that in the calculator here. So when I go to the graphing calculator, or just the calculator, I'll do 2 times 5.37. If you remember, I stored it as this a, because I'm not going to write exactly 5.37. I'm going to write this whole thing, and using a does that. So this is 2 times this number plus 10. And that's going to give me, I'm going to round it, but that's about 20.75. It's about 20.75. Now, there are a lot of things I can show as to why I need it to be this precise here. Let me start with this one. So first of all, here are my two answers. All right, 20.75 and 3.37 feet. Those are my length and width. Now, those are approximated. If I go back to the graphing calculator, let's say that I did 20.75 times 3.37. Okay, they'll be really close to 70, but they're not quite exact. 69.9275, you can see right there. Not quite 70. But if I get my exact answers, which are what? It's this a minus 2. It's this number here. And that's my 3.37 exact, whatever the thing is. And I multiply that with my other one, 2 times 5.37 plus 10. Guess what I'm going to get? Exactly 70. Oh, you can't see it. Exactly, look at that number. Ignore that. Exactly 70 right there. So that's what it evaluates to exactly. So I approximated my answers, and I never used my approximated answers to calculate other answers. That's why I can get exactly 70 back out there. I was hoping this problem would be factorable, but that's what that one goes down to there. I wanted to make sure that was it, and it is. It's too bad I had to talk more about approximation in the process of quadratic formula on that problem. I'm sorry, but that is what that one was. I'm not done with my stuff. I'm just kind of letting you decompress for a second. I'm at an hour, 3 minutes here. This is a longer one when I used all the methods and I had to use the calculator for that. All right, let's keep moving on forward. Solve the equations using any method. Write all irrational solutions in simplified radical form. That doesn't mean all these are not factorable, but I'm looking at the first one already, and it's not factorable. Let's say I attempted, because I'm going to use this later for quadratic formula anyway. Let's say I attempted to subtract, say I attempted to subtract 2 from both sides of this equation right here, right? When I do quadratic formula, I'll say a, b, and c. But if I tried to factor this, I'd ask myself, what two numbers multiply to make -2 and add to make -8? I think you can clearly tell this number is far too small to add anything to get -8 there. It's not factorable. So this will have irrational solutions, if any, real at all. So quadratic formula is waiting in the wings. However, it is waiting in the wings. Let me start with completing the square, shall we? I'll start with completing the square, as this thing is already kind of set up for that. I can add something here, and I'll add that same thing here. Divide -8 by 2 is -4. Square 4, I get -4, I get 16. 16 and 16. So here, this factors down to x minus 4, quantity squared. And on the right side, 2 plus 16 is 18. I will take the square root of both sides right here, square root, and I get x minus 4, provided here that I put plus or minus. Square root of 18, guys, is square root of 9 times square root of 2, so that will become 3 root 2, 3 root 2, so plus or minus 3 root 2. And if I add 4 to the other side, I get x equals 4 plus or minus 3 root 2. Nothing combines. I leave it as such. This is simplified. Radical form. These are exact answers. Unlike the word problem, which kind of needed for me to see not only what answer didn't work, but also kind of, I need to talk about feet. I can't say 4 plus 3 root 2 feet. That's kind of weird. I approximated the answer instead. All right, in green right here for quadratic formula, what do we got? We got a equals 1, b equals negative 8, and c equals negative 2. Let's evaluate the discriminant here. By the way, these aren't the only two problems. I think there are 4 more problems on the other page for this, so that's why I'm kind of trying to make haste now. I get b squared minus 4ac, which is 64, plus 8, which is 72. Remember, this is the discriminant, but I do have to take the square root in the quadratic formula, so let's figure that out as well. 72, I can pull out a 36 with a 2. That's 6 root 2, okay? So here we go. That's going to be x equals negative b, opposite of negative 8 is positive 8, so negative b plus or minus the square root of b squared minus 4ac, all that, all divided by 2 times 1, which is 2. Now, I can divide all of these things here by 2. I can divide 8 by 2, 2 by 2, and 6 by 2, and I'll be left with a 4, a 3, and a 1. And dividing by 1 means no fraction. So when I reduce that, I'm going to get 4 plus or minus 3 root 2. And that's my 2 answers right there for x, just like I got for completing the square over here. So this was not factorable, so I had to use either this method or this method. There was no other option. You can choose between those two. They're both relatively fast, but I think quadratic formula had a little more, not pain and suffering, just there you had to work with bigger numbers. You had to work with that fraction and know that you had to reduce those things, which really doesn't always pan out very well. So use completing the square when it's kind of a good opportunity for you. Like this problem, I don't think completing the square is a great opportunity. I don't have a 1x squared, and factoring a 9 out of 12 leaves me with a fraction, so I won't be completing the square here. That being said, I can reduce all my numbers. This may be factorable. I don't know yet. We'll check it out. Let's keep black here as we just reduce. Let's divide everything by 3, and that'll become 3x squared plus 4x equals 7. Because I'm going to solve using quadratic formula anyway, let's subtract the 7 over and get 3x squared plus 4x minus 7 equals 0. Now, this may be factorable. I'm thinking it actually is. So I'm going to try and solve by factoring here. What I'm aiming at in my head, I'm looking at 3x and x. I want to get a positive result here. So with a negative product, add and subtract. If I multiply this by 1, 3 times negative 1, I get negative 3. And then x times 7 is 7x. 7 minus 3 is 4. I think this one works out. You can double check through foiling and see if that works. I think that's the factorization. It looks like it is. This one was factorable. Back to another method where I couldn't guarantee they were factorable, like A. So no guarantees of factorization anymore, guys. You factor on your own merit. So anyway, 3x plus 7 equals 0. Therefore, 3x equals negative 7 and x equals negative 7/3. That's one of the two answers here. The other answer, x equals 1. Add 1 to x minus 1 equals 0. Add 1 to both sides, x equals 1. Cutting corners where I can. Okay, quadratic formula down below. A is 3. Remember, I have to use this form right here. Standard form set equal to 0. A is 3. B is 4. C is negative 7. Here we go. X equals negative, oh wait, hang on, discriminant. Here we go. Discriminant b squared minus 4ac is 16 plus 84 is 100. If you have, and I mentioned this to my students before, square root of 100, by the way, is 10. If you have a perfect squared discriminant, that means your problem was factorable. So I could have started with this first, gotten the discriminant, and said, okay, that means it is factorable. but I wanted to try the factoring myself. I think in my head I saw that it was factorable, so it kind of worked. All right, here we go. X equals -4. It's negative b plus or minus the square root of b squared minus 4ac all divided by 2a. That's 6. 2 times 3 is 6. So either x equals -4 plus 10 over 6, which is 6 over 6, which is 1, which is one of the answers, or x equals -4 minus 10 over 6, which is -14 over 6, which is -7/3. And that's what I got, I think, over here. Yep. So -7/3 there. So those are the two answers, quadratic formula and factoring. If I couldn't factor it, I would have only done quadratic formula in that problem. No completing the square whatsoever. All right. I do have 4 more problems in this realm right here, and this is the last problem, number 8 over here. So I'm eyeing an hour and a half, hopefully 90 minutes. I'm eyeing an hour and a half on this one here. All right, part C, 3 times x minus 2 quantity squared equals 54. You know what I'm really eyeing here is solving using square roots, and I'm actually going to start with that. Because I have a perfect square quantity here, I'm going to do this no matter which way I do it. I'm going to start by dividing everything by 3. So divide everything by 3, and 3 over 3 is 1. I'm still left with the x minus 2 squared here. And 54 divided by 3 is 18. So I'm starting in that. Okay. Solving using square roots, I'm going to begin by taking the square root of both sides. So the square root of both sides right here will leave me with x minus 2 on this side, and plus or minus, I think we did one of these earlier, that's a 3 root 2. Root 9 times root 2 is 3 root 2. And I add the 2 over, and I get x equals 2 plus or minus 3 root 2. And I'm done. That's it. Now, guys, this problem will not be factorable because I got irrational solutions. It will not be factorable. That being said, I could solve this by a quadratic formula and completing the square. I'm not going to do completing the square because I already have the perfect square trinomial factored down. But I won't mind doing quadratic formula for you on this problem. Sometimes some people just gotta do it in a way that they know best. So, or if it was factorable, maybe they'd want to do it this way as well. So what I can do is take this and expand x minus 2 quantity squared into x squared minus 4x plus 4, and that equals 18. So that's the foiling this thing outward. So this is, if you want to do quadratic formula on every problem, this is what you would have to do on this one. Some people wouldn't even know to divide by 3. Now I subtract the 18 over, I'll get x squared minus 4x minus 14 equals 0. One more time, this is not factorable. This is the stage on you could try and factor. It won't give you factorization. So you would have to use quadratic formula here. You could use completing the square, but you would go right back to here. So there's no point in going completing the square. The solving using square roots kind of is the completing the square. It's just the square is already completed. All right, guys, A is 1, B is -4, C is -14. My discriminant here is B squared minus 4AC, which is 16 plus 56, which is 72. Now, when I do the square root inside of that thing, the square root of 72 is that, once again, root 36 times root 2. We've seen that. That's 6 root 2. So when I do quadratic formula here, that'll be x equals -b, opposite of -4 is +4, plus or minus the square root of b squared minus 4ac, all over 2 times 1, which is 2. And we can divide everything here by 2. 4 divided by 2 is 2, plus or minus 6 root 2 divided by 2 is 3 root 2. So 2 plus or minus 3 root 2, and we get the same answer here and here. Those are the only two ways I could, should, would do that problem. Remember, completing the square was kind of the first one. I just didn't need to complete a square that was already completed for me. Okay, let me kind of separate these a little bit more. Can I get that hour and a half? We will see. Maybe not. I don't know how long the last problem takes to talk about, or these. X squared minus 2x minus 4 equals 0. Already, I know this is not factorable. Personally, I know it's not. You can try it, but it's not. All right, completing the square I'll do first here. I'm going to add the 4 over. Oh, it's hard to talk and write at the same time sometimes. You try it. I'm going to add the 4 over, and I'm going to add something new in here that completes my square. -2 divided by 2 is -1. -1 quantity squared is +1. So I'm going to add 1, add 1. This factors down to x minus 1 quantity squared. That's the number. Negative 2 divided by negative 1 is... Negative 2 divided by 2 is negative 1. 4 plus 1 is 5. And I take the square root of both sides. X minus 1 quantity squared. Square root of that is x minus 1. And here I have plus or minus square root of 5. I cannot simplify square root of 5. I'll leave it like that. And I add 1 to both sides. I'll get x equals 1 plus or minus root 5. I sure hope you guys note to try and take this, complete the square. Solve by completing the square if you have a non-factorable, positive 1x squared, and an even linear coefficient. This was 4 steps long. Quadratic formula, it won't be huge in comparison, but you know, cut corners when you can. This is really that kind of time where you look to do that. All right, quadratic formula. It's my last way to do this one. A lot less factorable problems here, as you can tell. We already did a lot of factoring. So here I got a as 1, b as negative 2, and c as negative 4. My discriminant is going to be b squared minus 4ac. Whoa, that's a negative 4. It's just fitting. Which is 4 minus negative, that's plus 16, which is 20. Now, 20 is the discriminant, but I need to take the square root of 20 in the formula. So that's going to equal root 4 times root 5, which is 2 root 5. All right? Let's go to work. X equals negative b, opposite of negative 2 is positive 2, plus or minus the square root of b squared minus 4ac, all over 2 times 1, which is 2. 2 divided by 2 is 1. 2 divided by 2 is 1, so 1 plus or minus 1 root 5 is just 1 plus or minus root 5. And I am finito caput. That's it. 1 plus or minus root 5. Yeah, the quadratic formula is pretty short in comparison as well, but you had to simplify the square root of 20. That's one stage. And just the discriminant bit, it just, you know, it depends on what you want to do there. All right, part E, no matter which way I want to try to do this, I sure want to move the x term over with the x squared term. That's a given, even if, no matter which form. So x squared minus 11x, get it in standard form, plus 28 equals 0. I do not want to complete the square. I do not like them, Sam, I am. It's an odd linear coefficient, so I'm not going to do the divide by 2 and square it. This looks factorable, guys. This one factors down to x minus 7 times x minus 4. If x minus 7 equals 0, then x equals 7. Hey, if x minus 4 equals 0, then x equals 4. Hey, I'm done. I would love to move on and just be done with that problem, but there are some quadratic formula heads, and they would love to see that form. Remember, completing the square is not a valid option for me. I do not prefer to use completing the square in this case. Quadratic formula, on the other hand, I don't prefer it, but let's do it. Quadratic formula, we get a is 1, b is negative 11, and c is 28. So the discriminant will be b squared minus 4ac. That's 121 minus 30. Wait, is that right? Did I do everything right there? 4 times 20, 4 times 30. Oh, it's 120. Okay, that's fine. It's minus 112 then. Minus 112, which is 9. I was thinking 122, and I'd think I'd get a negative discriminant. All right, the square root of 9 is 3. That's what's going to be as the b squared minus 4ac. Boom, boom. So let's go all the way up here. X equals negative b, opposite of negative 11. Hopefully you're feeling that out. Plus or minus the square root of b squared minus 4ac all over 2a. So either x equals 11 plus 3 over 2, which is 14 over 2, which is 7, or x equals 11 minus 3 over 2, which is 8 over 2, which is 4. Sorry for the rough, messy work. 4 and 7, 4 and 7, we got them. Wasn't factoring a lot easier there, folks? I think so. All right, last problem here before the final word problem, letter F, or number 8. So letter F's the last word problem here. 10 more minutes. Let's see if I can do this in 10 minutes. X squared minus x plus 25 equals 0. That's not factorable. Your factor of 25 or 25 and 1 or 5 and 5. I don't have a difference of negative 1 there. Too bad. I don't want to complete the square either because the odd coefficient, my only option I want to choose is quadratic formula. And it's already in standard form, so let's do quadratic formula here. A is 1, B is negative 1, C is 25. Okay. Here we go. Discriminant. B squared minus 4ac becomes 1 minus 100, which is negative 99. Guess what, guys? We could stop in Algebra 1, in Math 2 and Algebra 1, we can stop right here. Negative discriminant tells me there is no real solution. I cannot proceed beyond this and get real answers. Remember, we're trying to find out where these cross the x-axis on a graph. What if I graph this parabola here and they don't? There are imaginary solutions. If you are a math head and you're getting to the imaginary solutions, I'll tell you right now, your answer would be this. X equals 1 plus or minus 3i root 11 over 2. 3i. What is that I doing there? Well, it's something about complex numbers right there. So if you want to keep working ahead on that problem, that's what you'd get. All right? You stop here if you're in my class. No real solution. You're done. I didn't have to do the quadratic formula portion. That's it. All right. I probably can finish on time. Here we go with an hour and a half. Number 8. In the past, professional baseball was played at the Astrodome in Houston, Texas. Now they play at Minute Maid Park. The Astrodome has a maximum height of 208 feet. I don't know if that's true, but it sounds good. The height in meters, this is supposed to say feet. I had to change this from meters to feet. So the height in feet of a baseball, t seconds after it's hit straight up in the air with a velocity of 34 feet per second. Oh, I'm sorry. This is all. I had changed a bunch of numbers from meters to feet because I wanted to use non-decimal here. So 112 feet per second, it'll be changed on yours, is given by h of t equals negative 16t squared plus 112t plus 3. How long will the ball be in the air? All right, so the model's given for you. And there are a couple things I can do to play with this. And some of the, honestly, a lot of the information in the beginning is irrelevant. There's no question such as, would this ball hit the ceiling, the roof, which we could talk about by getting the vertex of this. I'm not going to do all that. That could be saved for another kind of thing. They're asking how long will the ball be in the air. This is hit straight up or thrown straight up or whatever it is. It says hit straight up. When it says how long will it be in the air, they're asking at what time will it hit the ground. Okay. Now, as much as you probably don't know how these parabolas look without going to a graphing calculator, the idea of this thing here is that it's a negative upside down parabola, and it has a y-intercept of 3 right here. So somewhere it's doing something like this up and down. And right here it's going down as well. There are going to be 2 different x-intercepts, or in this case t-intercepts. One right here and one right here. This answer is negative. That's no good for us if it's negative. This is time before the ball was hit. We're going to X that one out. Just like the garden one, I'm going to get a negative time answer, and it's going to be really close to 0, and I'm going to ignore it. It's not going to be used. There's going to be a positive t answer right here, whatever this thing is. This is the number that says how long it takes for the ball to come back down. By the way, there is a top height here. I wonder if it's above 208. I'm going to assume it's not. That's probably why they gave us the information and said it can still do it. They could have asked other questions like that, but they didn't. Anyway, we're going to look for this. T is like your x. So we're trying to find out when the height is 0, what is the value of t. So when does negative 16t squared plus 112t plus 3 equal 0? Now, I'll tell you what. You have 2 options. Well, I don't know if it's factorable. I'm going to assume it's not for now. They're pretty big numbers I would rather not play with. In fact, I would also rather almost multiply everything here by negative 1 and get 16t squared minus 112t minus 3 equals 0. Even if I tried to factor, I would do this. If I use quadratic formula, I'd do this. But I'll tell you what. I'm going to try and use completing the square here. I guess this number probably also divides from 16. I think that's 7 to 10 times. Yes. So I'm going to try this first, guys. I'm going to try and solve this by completing the square. I'm going to add the 3 over. Now, there's a reason why my students often won't try to complete the square here, because I have to factor a 16 out. I'll be left with t squared. I think that's a 7 minus 17. Oh, no, I'm not going to use completing the square because that's an odd coefficient. Never mind. Forget it. No completing the square here. All right, guys, quadratic formula it is. Let's go. Quadratic formula is my only option I want to choose here, so my discriminant, sorry about wasting your time there. Once I found out that was an odd number, no, I'm not going to divide by 2 and square that. I can, and I almost wouldn't mind it, but I think quadratic formula is fine. All right, so b squared minus 4ac. I don't know 112 squared, so here's where I jump to the calculator. Calculator friendly. I'll just do the whole thing. Negative 112 squared minus 4. Well, let's write it exact as written. 4a. Oh, a is 16. Hold on a second. I messed something up. I've been writing 1 so much. It's a 16. There we go. So let's go back to that. Minus 4a 16. C is negative 3. So this is the number 12736. So I'm going to write that as discriminant 12736. And I'll tell you what, because we're being using approximated, decimals and such, I'm not going to try and simplify this radical. Maybe 36, you can divide out 36. I'm not going to. I'm just going to use this number in the square root for my thing. So right now, when I use quadratic formula here, this can be t equals minus b, so positive 112 now, plus or minus the square root of 12736 all over 2 times 16, 2a. 2a is whatever, 16. Okay. Now here's the thing, guys, that I talked about this before, but you'll see it kind of pan out here. So t either equals 112 plus root 12736 over 32, that's 2 times 16, which is about something, or t is going to equal 112 minus root 12736 over, 32, not 36. I think I even said, I forgot what I said, over 32, okay, which is approximately something. Okay, I'm going to go to the calculator here. I'm guessing the bottom one's going to give me a negative answer, and barely negative. It might even be negative 0 point something. I don't know, I haven't done the problem, but I'm guessing that's kind of what it would be. So here we go. So I'm going to do 112 plus the square root of 12736, all divided by 32. And that answer, 7.0266, I'm going to write it as approximately 7.03. I'll show you it later. And then I'm going to do that same thing, and I'm going to subtract that guy right there. And that'll be, look at that, negative 0.03 about. I'm going to leave it like that. Okay, so here's what you're going to see here now that I use the calculator, because I'm almost done. I got 2 different answers for t. This is time. I can't have the ball. See, this is before the ball hits, so this does not kind of apply to our model. Our domain starts at t equals 0 seconds. So this part is ignored. The negative second answer is not true. This one is the correct answer, though. How long will the ball be in the air is also asking how long will it take to hit the ground after it is hit, after it's hit by a bat. And the answer is 7.03 seconds. That's an approximation. You saw 7.02. 6683995, but that's using the quadratic formula for that. You can see taking time to simplify that radical would not have been worth my time, especially since I'm not actually attempting to write an exact answer this way. I wanted to approximate it anyway, and there it is. All right, so that ought to do it for this one, guys. That is the whole review for this. A lot of stuff. Let me just go back and show a lot of different ways you can do each of these problems here. A lot of different methods. They're all color-coded. Blue is always factoring, purple is always completing the square, that little red bit's always square root, and green is quadratic formula. A lot of work, a lot of show. That's why it took 90 minutes to do and explain it all. Yeah, if I do it on my own, even doing these, it would be shorter because I'm going to skip some steps for myself. Always find greatest common factors, guys. When using a calculator, know your order of operations and all that kind of jazz. If you have any questions, please leave it in the description section below, or comment section below. I promise in the description section to upload you a PDF with corrected information where it doesn't say compete the square, it says complete the square, and where it doesn't say the meters value instead of feet. All right, so I finished within an hour and a half. That's good. Also check Q&A Power Hour video that's going to be up in a moment's time as well for you for whatever questions you had. That'll do it for me, guys. This is Mr. Robinson. Take care.